say you have departments like say finance, 15 people, IT 20. You want to address it in a way that will make sense in terms of conserving IP addresses and making them to be able to work together. So those are the three key areas we want to touch on today. And I'll give you your assignment. Okay, so I said IP addresses were logical identifiers of nodes on a network the last time we met. So it's how network nodes communicate on the network through their IP address. And the IP address is in the layer 3 of the OSI. Is in layer 3. Is in layer 3 of the OSI. So you remember your 7 layer of OSI where you had your application, your presentation, your session, your transport, your network, data link layer, and physical layer. So this is 1, 2, 3, 4, 5, 6, 7. Those are the 7 layers. So networking is in layer 3. That's where you have your logical addressing of the network. Okay. And then we said that we had classes. We had class A. We had class A, if you can remember. And we said class A were addresses that started with 1 to 126 with class A IPs. So in the first octet, if you see IPs 1 to 126, that means that's your class A. And then we had class B. Class B was 128 to 191. It's very important you understand this. Then class C was your 192 to 223. These are the major classes we use. We have other classes like the class D, like I said, that's multicast, and the class E is for experiment and is reserved. So you don't really need to bother yourself about that. And then class A, we said was a /8 subnet mask. Class B is a /16. Class C is a /24. And I told this slash notation is the same thing. If you want to write out, so the way you get your slash notations, so /8 just means 255.0.0.0. Because if you write all this in binary, 255 is all one. So that 1, 2, 3, 4, 5, 6, 7, 8 dots. All these zeros will be in zeros, plenty zeros. 1, 2, 3, 4, 5, 6, 7, 8. So I'll no need to write the other one, dot 0, dot 0. So if you count this, this is 1, 2, 3, 4, 5, 6, 7, 8. So that is why this subnet mask is the same thing as saying /8. You understand that? Please,
Yes.
are we together? Okay.
Yeah,
So,
yeah.
all right. So that's a /8, which is a 255.255. Then we now have this /16. If this thing will just clean properly. Wow. Okay. I need to start browsing some good whiteboard someone can use. All right. So we have 255.255 dot. No, let me just clear everything. Okay. So in that same vein, 255.255.0.0 in all binaries will be 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0.0. And if you count all this, this would be the same thing as writing /16. So the same way too, if we had 255.255.255.0, this would be /24. Because by the time you turn all these bits, so there's 8 here, there's 8 here, there's 8 here, That's 24. So that's how we get the slash notations for subnet mask. That's how you get for subnet mask. So these are classful subnets. Remember, these are classful subnets. So your class A is anything that starts from 1 to 126 and has a subnet mask of, by default, class A has a subnet mask of /8. So if you see an IP that is 10.172.16.0, mere looking at it, because the first octet, this is what I refer to as the first octet. This first octet is in this range, 1 to 126. So that means this is a class A network. So if I have something like 200 dots, that means this is not a class A because it's not within the 1 to 126 range. So that's how, from the first octet, is how you know what is your class A or your class B or your class C. I don't know if you understood that. That's pretty clear, right?
Yeah, it's pretty clear. But I just want to get something clear. When you say something is classful, what do you mean?
Okay, so once it's classful, that's you've not subnetted. So there's a way you can take a classful network and subnet it and it becomes classless. So it doesn't really belong to a class. So if I have, so by default, for instance, now we actually move. This is fast forwarding, but just to answer your question, by default, this network 10.1.0 dot. Okay, let me just make this. Let me say dots. This eraser is beautiful. 10.1 dot. Let me say 5.5.0. By default, this fits into the 1 to 126 in the first octet, Abi.
Yes.
So this should be a class A. But if I take this IP address and I give it a /24 or a /25, it's no longer in its class, because
Okay.
/24 means you get, I've taken it from its
Class A
natural
to class
default
C.
class,
Yes.
yes, to a class C. So I've made it classless. So by subnetting, by trying to readjust this, I've made it classless. So it's no longer belonging to the class it's meant to belong because of the subnet mask, which now says this bit is now the network portion. For class
Okay.
A, only these bits, only the first octet is the network
It's a
portion
network.
because it's a
Yes.
/8 here. So that's what I mean by it being classless. So when we start subnetting, we'll see what classless. So this classless is the same thing as VLSM. So when you hear about VLSM, it's the same thing as classless, which is the same thing as CIDR. It's called classless interdomain routing or virtual length subnet, variable length subnet mask. So your subnet mask is varied. It's varied from what is meant to be the default classful subnet. So that's
Yeah.
so
Thank you.
because the reason is because classful networks are very wasteful. So if you put a class A network in your organization, and you know how many IP addresses there are. Now, a class A network is like I said, is a /8. So that's a 255.0.0.0. And I told you, wherever you have 255, that is the network portion, and the zeros are the hosts. So this is the number of hosts you can have. So if we take this and put it into binary, we find out that 255.0.0.0 is 1, 2, 3, 4, 5, 6, 7, 8 zeros, 8 zeros, 8 zeros. You put the zero so that it will confuse you. So that means we can have 2 raised to power 8 networks, because the ones is what tells you the networks, while the hosts are the zeros. We can have 8 times 3, that's 24. 2 raised to power 24 hosts on a class A network. Remember the other time we had almost 116,000 something 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 when we're going through the other class number of hosts. So it's wasteful. just putting a class A. So you want to vary the subnet max, which is subnetting, which is VLSN, so that you can have a much more um, smaller space for you to play with. Any other question? In terms of the classes, are the classes clear? Class A, Class B, Class C, and how to identify them?
Yes, it's clear, but there's something I want to get. Sorry for kind of going back. So when you
No
say
problem.
wasteful, is it because we don't have much network, or because you have much hosts and network? So making it
So
not wasteful, we have to get more network than host. I don't know if I'm. Yes.
yeah, so you have both too many networks you're not using and too many hosts. Both the network and the host you can't use. So 2 raised to power 8, that's uh, that's that's about 256 networks. I don't think you'll be an organization that has 256 say units, because the reason why you want to have sub networks is because you have different units or different departments or different systems you want to interact and isolate. So you get, so me having 2 raised to power 8 networks means I want to have like 256 sub networks inside that network, and that means that subnet. That's where the term subnet come from. So it's wasteful when I'm just going to use maybe say 4 networks. So I just need 4 subnets out of that class A. So what that means is I'm going to use our class A, and then I'm going to tie it down for just one network. Because by the time you assign it to finance department and you use it as a class full, it means you cannot assign it again to say IT department. So you've wasted 255 sub networks inside finance when you just wanted to address just one network. So that's where the whole subnetting and everything comes into play. Because if you continue like that, it means you run out of IP addresses even before your organization has the opportunity to scale, even before what your application or your development or whatever you're trying to put together has that opportunity to scale. So right from the onset, you have to be as conservative as you can with your IP address, because you're looking for how you scale and how it's going to be yeah, easy for you to scale, so that you don't run into issues where people are running out of IP addresses because they are spinning up too many servers. You know how it is. Production can come. We need 2 more servers. We need 3 more servers. Those are all IP addresses you need to assign. So if you are not conservative right from the start, it means they'll come to a point where they'll spin up servers. They say, this server, I want it to be in the dev, dev environment. So what does that mean is they want it to be in the dev subnetwork, and it shouldn't be able to reach the production. So that means it's the subnet they're using to isolate. So that's where the wastefulness comes into play. So I don't know if that answers your question.
Yeah, perfect. Thank you so much.
Does that answer your question?
Yeah. Thank you. Thank you.
Okay. So just to recap, so that's we'll recap and then we'll move forward. So 128 to 191. C is 192.2.2.3. Now, as you keep on going with these things, it will get clear. Now, if you look at this, you notice that there's a range that is kept between class A and class B. That is the 127. Don't know if you notice. Now, this 127 is reserved. 127.0.0.1 is reserved for loopback in most systems. Most systems, PCs, servers, and the likes. 127 is always reserved. So that's why it doesn't really belong to any class per se, because it's just reserved for you to be able to test that there's IP, whatever, I can't remember what it uses it for, but I know PC is mostly reserved that. Okay, then moving forward, we touched on the fact that we had public and private IP addresses. And I said Public addresses are addresses you have on the internet. So this is the internet. On this internet is where you have things like Google, uh, Yahoo, your Facebook, and all that stuff. So you as an organization now, you've paid for, say, a link. Maybe MTN is your provider, depending on whatever you're using, whether you have a dedicated link or you're using their base station. And then you have your mobile sets, whatever that's connected to that, or you have your Wi-Fi or your MiFi, whatever you have. And then this is just your MiFi connecting to your PC. So on this internet, only public IPs are routable because every device here, all these servers you are visiting actually have public IPs assigned to them. That's the only way you can reach them. That's how the internet knows where they are. That's how the internet is okay. Oh, if I'm going to Google, I should go to wherever I'm going. If I'm going to Cisco, I should go to wherever their server are. But you sitting down here, what you're going to have is a private IP. Is a private IP. So what happens is that there's a translation between the private IP and the public IP that your service provider, MTN, is going to give you for the purpose of you browsing the internet. And that process is called NAT, which is Network Address Translation. So it translates, it hides your private IP. So to the internet, they're like, oh, is MTN that is browsing? Or is this MTN's MiFi that has this public IP that is browsing? So when it returns to you, the protocol does whatever it needs to do and then sends the traffic to you because it's the one that did the NATs. So that's the difference between private and public IPs, and the ranges are, so for private IP, the ranges are for class A network, the range is from 10,000 to 10,255 255. This is the range for private IP for class A network. Anything outside of this is a public IP. You don't use it inside your private organization. You don't use a public IP inside, except you're just doing a lab, for lab that you know is not connected to the internet or anything like that. Because every public IP address that exists, someone has bought it or paid for it. Okay, so you cannot just pick a public IP address out of space and then you are connecting to the internet to route it. You won't get to where you are going, and then you might be sanctioned or something like that. So this is the range for class A. For class B, the range is 172.16.0.0 to 172.31.255.255. And then for class C is 192.168.0.0 to 192.168.255.255. So those are the ranges for your private IPs. For class A, for class B, for class C. We'll go through a couple of exercises or examples so that you can better familiarize yourself with those IPs. Let's quickly move forward so that we can cover as much as we want to cover. Okay, so that's that about IP addresses, their default subnets, and the private address space. Now, okay. All right, so let's just do some identifications in the class. So when I write out the IP address, you can tell me what class it is. All right, so for instance, we have 10.250.1.1. Which class of IP address is this?
Class A.
Okay, that's class A. Okay, we have 150.10.15.0. Which class is this?
The second
Which
one is
class is
class
it?
B. And the third one is class C.
The third one is class C. Okay.
Class C. Yeah. And the second one is class B. 150.
Okay. So we have 148.17.9.1.
Class B. The last one is class B.
Last one is
The last one is
okay. That's great. That's great. You guys are catching along. All right, let's try for public and private IP addresses. So we have 193.42.1.1. Is this a public or a private IP? This is a public or a private IP?
The first one is a public.
Yes, it's a public. The second one,
Second one is a private class A.
okay, yeah. So this is public.
yeah.
This is private. How about the third one?
It's private.
Did you say private?
No. Is it dot one,
It's
dot one,
public.
dot one? Okay.
It's
Public. Yeah.
It's
Because of
public.
the second, third, fourth.
Okay. So yeah, so that's it. So once you just see something outside of the ranges I said it's a public, then those ones are private. Okay. That's fine. That's great. That's great. Okay. All right. So let's move forward to the bone of contention, which is subnetting. So let me see. So I'm going to go through that binary to decimal conversion again. Like I said, this is for subnetting. This is what you should be concerned with. 128, 64, 32, 16, 8, 4, 2, 1. Because this corresponds to 1, 2, 3, 4, 5, 6, 7, 8. The 8 bits we have in an octet. So that means this is the basis for your conversion. So I'll just show you how this works. So that means if you have binary, you want to convert this one, everything, all ones, all you need to do is add. So this one is equal to 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is equal to 25. Is that 255 or 256? 255. It's as simple as this. So let's say that we have, let me walk through some examples. Let's say I have 1, 0, 0, 1, 0, 0, 1, 0. I have this binary to convert to decimal. All I need to do is put this alongside that my 128. So this is 128, this is 64, this is 32, this is 16, this is 8, this is 4, this is 2, this is 1. So I'm going to only add the ones because 0 will cancel out. So this is going to cancel. Are you getting it? So that means that binary is the same thing as this is equal to 128 plus 16 plus 2, which is, can someone help us do that? So that's 128 plus 18. It's
146.
that's like 146, right?
146, yes, 146.
Okay. So you get I don't know. Well, this my jargon. I just cleared everything. Let me write it out again so that without the jargon, please. 10001. So we're converting 100 100 So I said this is 128. This is 64. This is 32. This is 16. This is 8. This is 4. This is 2. This is 1. So I'm just going to add this, this, and this, which is what we did, and we got 128 plus 16 plus 2, which is to 146. So this is a fast way to convert between decimal. So by the time you keep working with this, you don't even need to write this out in your mind. You just begin to know that the first one is 128. I just keep to 16, 2. As in, by the time you keep on practicing, you won't even write them out the way I'm writing, but I'm writing it out so that it can give you a good background. Let me do something else. So let's say we have 0 triple 1, so 0 triple 1, 0 1 1 0 1 1 1. We want to convert this. All right, can we write out that one? The first one is what? 128. The next one is what?
64.
64.
The next one is what?
32.
32.
Yeah, so you're just dividing by 2, 16,
8, 4,
4, 2.
2, 1.
Okay, so so to convert this to binary, please ignore this one. We'll have, so to be, what is the first number we are adding?
64
Plus
32
plus
16
plus
plus 4 plus 2.
plus 2 plus 1. So that will be 8 in decimal. Should be like
119.
119. Yeah. All right. So it's pretty straightforward. It's far better than you having to do 0, 1, 2, 1 times 2 raised to power 0, 1. That's for primary level and secondary level. We are far more advanced than that to be doing that. It's time consuming, and that's not actually what you want to arrive at. You want to be able to quickly convert so that you can go on to the business of subnetting properly. So we'll just take two more, and so that everybody can walk along with us. Okay, all 1 2 3 4 0 1 1 0. All right, can you walk me through this one?
So
That
this
will
should be
be
128
128 plus 64
Okay,
plus 32
okay,
plus 16
plus 16
okay,
plus 4
plus 4
plus
good,
2
plus 2.
That-
246.
246.
Um, is that from my end?
Hello, is it?
It's general.
Okay.
So, is it? Can you hear me?
Yeah,
Hello, is it?
can you hear me?
Okay,
Yeah, I no
yeah.
longer see my screen.
Can you reshare your screen again?
Oh. Okay, I'm sharing it now.
Okay, fine. It's okay.
Okay. All right, so can we quickly work this one so that we can go to decimal to binary and then move on to subnetting? Yeah, who is trying this one?
Okay, this one is 16
plus 2 plus
plus
1.
2 plus 1.
This is 19.
That's 19.
Yeah, that is brilliant. That's great. So you see, it's clearer than it was in the other class. Okay. Okay. All right. So, but decimal to binary is almost an inversion of that. So, but this time around, you take the numbers and you step it out. All right. So we have. Let me just write those numbers again. 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So assuming I was converting a decimal number, say 238 to binary, what I would do is, can I subtract 128 from 238? Yes. So yes is 1, meaning yes. So whatever is remaining, 238 minus 128, what is remaining? Can someone quickly do that, please? 238 minus 128.
110, 110, 110.
110. I can subtract 64 from it, Abi. So that's yes. What will be remaining?
Giving us 46.
46. I can still subtract 32 from that.
Yes. Giving us 14.
Giving us 14, right?
Yes.
I can still subtract 16 from that, right?
No, I can subtract 8.
Okay,
I can't
8,
subtract,
right?
so that's 0. So that's, I can't subtract 16, Abi.
Yes.
Because
that's
it's 14. So that's 0. I can subtract 8, right?
Yes.
Yes.
Okay.
That's 1.
Leaving us with what?
4. You can subtract, leaving us with 6.
6.
Leaving us with 6. So I can subtract 4 and I can subtract 6. Then 1 becomes 0. So that means this is 238 in binary. 1110, 1110. Did you get the concept?
Yeah.
And so you carry the binary and go through this, and then you answer yes or no if you can subtract these blocks from it. So let's try like 2 more. Okay, let's try 200. Let's try 200. So we have 200. We have 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So 200, yes. I can subtract 1 to 8. That will leave me with, my math is rusty here.
72.
So just 72. I can subtract 64.
64,
that will
yes.
leave me with
8.
that will leave with 8, Abby.
Yes.
So, so that is 0, 0,
0,
1,
0, 0,
0, 0, 0. So this is the binary. This is the binary of 200. So you see, it's pretty straightforward to convert between binary back to decimal and decimal back to binary. So yeah, great. You guys have done great. So let's move on. Now I want to take this in a way that it will build on what we have so that you can get it. So let me not just jump straight. Okay. Now remember we said that subnet max is what tells you the host portion in a network, right? Are you there?
Yes. Yes.
Okay, great. So assuming these are classful networks, I'm going to, because we've not started subnetting, let's just keep it at class. Remember, class A is 255. Let me just write it out here. 0.0. B is 255, 255, 10.0.0 and C is 255.255.255.0. So assuming we are working with classful networks, okay, and I give you this IP 177.100.18.4. Now, first and foremost, you want to know which class this falls in. Which class does this fall in? This should fall in class B, right?
B.
Yeah. So class B says this is the subnet mask. So that means wherever I have 255 is the network portion. So that means 177.100 is the network, right?
Yes.
So any IP that starts with 177.100. So if I have another IP that is 177.100. Maybe say 20.2, these two IPs are in the same network by reason of this subnet mask. Is that understood?
Yes.
Okay. All right. So what we're doing now is identifying network and subnet and host portion. So you could, once we can identify what is the network portion is, what the host portion is, we'll go into something else so that we build on that. Okay. So I'll give you this IP 119.18.45.0. All right. So can you tell me what the network portion in this network is? Classful now. First, what class is this?
This class A.
Class A.
Yeah, class A. Yeah. So the network portion is which one?
255. What's the portion?
Yeah, the
119.
subnet is 255. Yes, so
Yes,
that's
255.0.0.
119.
255.0.0.0. Yes.
So this, all right. So the network is 119, right? So this is the
Yes.
network. Why these are the hosts? Okay, beautiful. Let's move on to the next. We'll just take like 5. So how about 209.240, 209.240 dot 80.78. What's the network portion here?
Network portion is the first three is class C.
That's class
Yeah.
C. You have the
That's
first
So
class
the
three.
next,
first three.
so the first three.
First three octets.
Beautiful. Okay, beautiful, beautiful. So okay, let's move on to looking for something that will be in somewhere else. Let's hold on. Okay, so 158.98.80.0 network portion.
This is class
First
B.
two octets. Class B.
First two octets.
First
Okay,
two
so
octets.
first two is a network. All right, that's great. All right, so let's go to host portion. So I'll be writing some other one. You tell me what's the host network type. So for 10.15.123.50. What's the host?
The
Yeah,
host
Class
The
A.
last
The
three
last three
octets.
octets.
class A.
last thing. Okay, I think you guys are getting the hang of it. So let me just move forward. You guys are getting the hang of it. You're getting the hang of it. Okay. So now you know the host and the subnet. Now there's a way an IP address is inside a subnet. So they'll give you the IP address and ask you what is the network that it belongs to. For instance, when we wrote the one we just wrote now, what was that again? Let me see if I can get where I got that one. Oh, sorry. Just hold on. Where is it? Where is it? Where is it? Where is it? Okay, yeah. When we said 10.15.123, 125.50, whatever, and we said this was a class A. So that means the network, we said this was a network, right? So that means the network that this IP address belongs to is 10.0.0.0 network. Do you understand that?
Mm-hmm.
Yes.
Yes. So that means this is the network it belongs to. then you now have it inside. All right, beautiful. Okay, all right, so we'll just move on to that. So assuming we had something like 188.10.18.2 with a subnet mask of 255.255.0.0. Yeah, what network will this belong to?
It belongs to
188 dot
188.10.0.0.
beautiful. So it will belong to 188.10 0.0 network. Yeah, exactly. That's what I wanted to find out. And we had something, say 192.168.49.52 with that subnet mask of 255.255.255.0. It will belong to this network, right?
Yes.
Yes.
Class B.
Dot zero, Abi.
Zero.
All
Yes.
right,
Yes.
all right, all right. So you would realize that anytime we want to find the network, we use the subnet mask that is all ones. So that means there's something that corresponds one with network and something that corresponds zero with hosts. So
Yeah.
this is very key to subnetting. It means if you want to create more subnets, you have to borrow more ones. You have to borrow ones to create more subnets. If you want to create hosts, you have to borrow zeros. I will show you what that means when we start the subnetting. So ones will give you more subnets, zeros will give you more hosts. So that means in this network, if I had changed this side to zero, that means I'll have more hosts than this subnet had already had. That means my subnet mask will change, yes, but I will now have more hosts and lesser subnets. But if all these ones are ones and I borrow one, that means I have lesser hosts and more net subnets. So you just get that in your head. The more ones you have, the more subnets you have, and the less hosts you have. And the more zeros you have, the more hosts you have, and the less subnets. Okay. Oh, that will come in handy as we move on. Move on, move on. Okay. Okay. So another formula you need to know is subnets equals to 2 raised to power n. So this n here will tell you how many ones you need to borrow. Y hosts is the same 2 raised to power n, but minus 2. Now I'll tell you why you minus 2. Now in every network, you cannot assign two of the IP addresses. The first, the network address, you can't assign a network address to a system, and you can't assign the broadcast. I'll show you what that means. So we had 10.15.25.2 network. So yeah, IP address. And we said that this was in the 10.0.0.0 network. Remember, so this network, this is the stats of the network. This is called the network address. You cannot assign this network address to a node. And you also can't assign the subnet, the what they call it,
The
broadcast.
broadcast.
Yeah, so the broadcast of this network is 10.255.255.255. You know why? Because this is the very last IP address that is in this range. If you just add one more into this place will turn to 11 and it's no longer in that network. Do you get that?
Yes.
So if we add any bits, this will turn to 11. The first octet will turn to 11 and it's no longer in this 10 network. So the very last and the very first networks cannot be assigned. The first network is the network address. The last network is the broadcast. So that's why to get the usable host, you have to subtract by 2. So what that means, no, I can't use let me use a class C. Class B is always 2. So that means in a class C network of 192.168.set25.0, and this is a class C 255.255.255.0. So what that means is, for me to know the number of hosts here, all I need to do is 2 raised to power n. Remember, for hosts, n is the zeros. So how many zeros do we have in this subnet? We have 8 zeros. Good. That is 2 raised to power 8, which is something as 256. But I have to subtract those 2.
Minus 2.
That, yes, that can be used. So that means in this class, in this network, we can only have 254 hosts. So these are the only usable IP address we can use. Once we have more than 254 servers, bro, there's no other IP we can assign. It means we have to now create a new IP address for the next set of servers. So that's what I'm saying. It's very important that you subnet and you know how the growth is going to be in the future, so that you don't run out of IP address and then you now have to start looking for ways you can patch up the network. So that's how to know the host. So n zeros will give you host. Why? If you're calculating for network, so to calculate for network here will be 2 raised to power n will be 8 times plus 8 plus 8, right? That is 24. 2 raised to power 24, right? So that will be the number of networks that we'll have, or subnets we'll have inside this IP address. Okay, so building on that, we've got the basics. Let us move on to subnetting. Yes. It is this. Okay, so this is the question. Normally, when you are given subnet questions, they give you an IP address, a classful IP address, and they want you to subnet it. So by the time you subnet it, it return classless. So assuming you were given this IP 192.168, sorry, that's not what I want to write. That's not what I want to write. Then 192.192.10. Which was the time? Oh, it's 10 o'clock. Okay. So assuming you're giving this IP address, now by default, you look at this. This is a class C, right?
Yes.
Yeah.
Yeah. And you're asked to subnet it into 14 networks. So we are telling you that we want this IP that was initially a /24, and it could give us 2 raised to power, was it 24 networks? I don't want it to give me all that network. I just want 14 networks out of this. So what you now do is remember your formula. So you ask yourself 2 raised to power n is equal to 14. So that means what is n? How many ones do I need to borrow to be able to accommodate? Now remember, this is not like maths. It's not like it has to be equal to. So how many n's do I need to borrow to be able to get this? I think is it 4?
4, please.
Yeah, because 2 raised to power 4 will be
yeah.
16, right?
Yes.
Okay, so all right, let me show you what I mean by borrowing. Can I still have space in this? This is small. Okay, let me try and see I can conserve space. So we are doing 192.10.10.0, and the default subnet is 255.255.255.0. We said this is a class C network, and they want us to subnet it into 14 subnets. And we just did our formula now, and we saw that we needed to borrow 4 to be able to get that 14. So what that means is I'm going to write out the initial subnet marks in all ones. So there's 1, 2, 3, 4, 5, 6, 7, 8. Oh, what happened? What happened? Where's this? Oh God. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6, 7, 8. So this is what the subnet mask is in binary, right?
Yes.
So I want to add this 4. So because you have to make it to be consecutive. So I can't go and say, okay, I had all ones here, all ones. I don't know how to put that. How do I explain this? So where I'm going to add the 1 is at the beginning where I have ones. So rewriting this subnet mask, I'll have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, this one that was initially all zeros, I'm now going to borrow 4. 1, 2, 3, 4. Then leave the others the way it was. Can you see that?
Yes.
So that means my new subnet mask now becomes 255, 255, 255. And this is why that's your conversion was very important. Plus 128 plus 64 plus 32 plus 16, right? That is 240. Did I convert that to decimal properly? 128 plus 64 plus 32 plus 16.
Yes.
Yeah. So that means this is your new subnet mask, which is same thing as, remember, this is 8, 16, 24, 25, 26, 27, 28. So this is same thing as a slash 28. Now, when you're subnetting, there are 2 things you are looking out for. What will be the new subnet mask after I've subnetted? And then what is the incremental value? Now, the incremental value is how do I step out the network? Remember, class full, there was no increment. It just started from 192 to the last IP. But now that you've subnetted, things will change. The way you calculate incremental value is you ask yourself, they call it the lowest high order bit. A high order bit just means a bit that is 1. A low order bit is a bit that is 0. It's as simple as that. So in this one that you just added, this one here, have you seen this guy here? Huh?
Yes.
That is your lowest order bit. I remember in that our 128, 64, 32, this guy was what? This guy was what? 16.
16, yes.
So that means your incremental value is 16. So what that means is your new IP now is now 192.10.10.0 slash 28. That is 240. Incremental value of 16. So because this is the last octet, right? That we did that manipulation. So that means our increment will be in the last octet. So that means the next network will be 192.10.0.16. The next network will be 192.10.0.32.
32.
If you keep skipping it, you will see that you will get till the last network, which will be 2. I think we should just write it. Will be 2 something, and you find out that inside all these things that you've skipped, you will not have more than 14 subnets. So that means you've gotten the 14 sub networks you wanted. So you can give this network to finance, you can give this network to design or whatever. let me just cancel this. Let me erase this and write it out so that we can
I think you can add more white paper instead of clearing it.
really, really.
Yeah,
This
plus
is the
that
first time.
plus.
Oh, the plus sign.
Yeah,
The plus sign. The plus sign. Beautiful. Beautiful. Are the students seeing this one? Oh, yeah, yeah, yeah. True, true, true. Beautiful. I just browse it up like 10 minutes before we started. So 192.10.10.0. The next network will be 192.10.10.16.
This is
So that means, yeah, yeah, 192.10.10. And you've subnetted.
32.
Like,
Yes,
yeah, like joke, you've subnetted. The next one is 48,
48.
right? The
Yes,
next one is
54.
54. Now, if you keep going, I can't remember the last subnet to be what now. I can't remember, but that's a lot of math. Please come get the baby. Sorry, I'll be right back, guys. Let me see this guy. All right, guys, sorry about that. Do we still have people? Yeah, okay, we still have people, guys. All right. So I don't know. Are we? Yeah. Wait. So I was stepping out the IPs. Can you hear me?
yeah, we can hear you.
Yeah. Sorry about that baby. That's how he behaves. So we step it out. So now to know the ranges. So the last IP here will be what? That will be 192.10.10.15. Are you seeing that? The same thing here, 192.10.10.31. So that means in this network range that you've subnetted, you can't assign 0 and you can't assign 15. So 10.59 becomes the broadcast of this network. That means you want to assign, the first person you give is dot 1, dot 2, dot 3, dot 4, till 14. So that means in every subnet, if you look at it, you can only have 14 hosts. Have you seen that as well?
Yeah,
Yeah, in every subnet, you can only have 14 hosts because it's a slash. It's a slash that, yeah. So that's how you do subnetting. So, but in this, we wanted to get the networks. Yeah, wanted to get to networks. So this is that. So 2 raised to power n, you reserve ones, then you calculate your new subnet mask, and then you
I can't hear him. Is it my network? My network.
I can't hear too.
Oh,
It's not your
okay.
network. I think it's off.
Okay.
Hello, AC. Hello.
So sorry, guys. I had to switch my network. My network is my Wi-Fi went off, and sorry about that. So I'll proceed to share my screen again. My screen. Can you see my screen?
Yes.
Guys, can you see my screen? Hello, can you see my
Yes,
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 yes, yes. We can see your screen.
when you see my screen? So I can see. Okay. So, okay. Jesus. Okay. Let's do a network again, and then let's look for something. Can do subnets. Okay. All right. So let's move on. So we have this IP address 210.100.56.0. Okay. And we want to get 6 subnets from here. So we want to have 6 subnets. We have 2 raised to power n equal to 6. So that
Your
would
line
be
is breaking. Yes, sir.
2
Your line is breaking.
raised to power 3, right? Which equals
Hello, yes, sir.
8. So
Hello, yes, sir. Your line is breaking. Like your line is
right,
breaking.
that was for 3. Is that is okay? I think you should be able to hear me better now. Can you hear me better now?
Yes.
Okay. So I'll just try and sorry for all the hindrances. We'll finish before 11 actually. Okay. Let me just clear this. So I said I wanted to move on to the next one that we just do. So we have 210. So 210.100.56.0. So and we are asked to subnet it into six subnets. So we are trying to get 6 subnets out of this block of IP. I said the formula is 2 raised to power n, right? So 2 raised to power what will get me closer to this 6? I think it will be 2 raised to power 3. 3. 6 will be too large.
Yes. It's true.
2 raised to power 3. So because 2 raised to power will be 8, which is good enough. Okay. So that means so sometimes now that you know that this is a class C network, right? So there's no need you writing out all the ones you are going to do between this, and this. You get. So this is in terms of their subnet mask. This is 255.255.255.0. So you can just keep writing out these 255s in binary because you are not going to change them. what you are going to change is the last octet, that is zeros. This is the one that gives you something to play with, right? When you're trying to increase the number of ones. So I'll just go to that last octet and add my 3 ones. So my last octet will be 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Oh, sorry, it's 3. 1, 2, 3, 4, 5. Don't need this one. So that is the 8 that we need. So we convert this to decimal. This will be 128 plus 64 plus 32. This should be 224, right?
Yes.
Okay, so that means my new subnet max, after I've done this thing, will be 255.
Wait, sorry.
Yeah,
Can you
yeah.
step back a bit? You
Okay.
get that?
Okay. So, okay, all right. Okay, let me just scribble it. Okay, you said I can do plus. Yes, I can do plus. All right. You've seen this new one, Abby? Okay.
Yes.
Beautiful. Okay, so we're doing 210.100.56.0, and we need to get 6 subnets. You got up to that point, Abby?
Yes.
6 subnets. And we said to be able to get 6 subnets, we need to put it through this our formula, 2 raised to power n. And we said the closest that will give us 6 will be 2 raised to power 3. Did you get up to that?
Yes.
Okay, so that'll be the 8. So 6, 6, 8. 6 is inclusive in 8, which is fine. So that means I need to reserve 3 ones. That is 1, 2, 3 within the initial subnet. So that means I now go back and I write the initial subnet. This is a class C. So that means the initial subnet, initial subnet will be 255.255.255.0, right?
Yes.
And then this initial subnet in binary will be 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dots. Now this is the one I'm going to play with, which I'm now going to add my 3 ones that I want to borrow, right? 1, 2, 3. And this one will complete. So that's what I'm saying, that there's no need to write out all these ones. It's just taking up space, taking up your time. This is the only octet you can play with. So just bring it out and say, you know what, 1, 2, 3, 4, 5, 6, 7, 8. The last octet is what we are working, because that's the only one that had 0 in the subnet that we can play with. So we are going to convert this. Yeah. We are going to convert this to decimal now. Converting this to decimal, we pass it through that about 128, 64, 32. So there's 128 plus 64 plus 32. That is 224.
Okay.
As the
Yeah.
last octet. So
This
yeah,
one.
you get. So that means our sub. Yeah, this is where you got. Yeah. So that means our subnet now is no longer 255.255.255.0. Our subnet will now be 255.255.255.224.
224.
Exactly. So that is let's go to another page. Okay. Can I copy and paste? I cannot copy and paste. Okay. 210.156 to 10.156. All right, so that means this becomes 210.
Copy and paste.
I'll go through it in my spare time and say I can do all this, so to be easier in my next class. So this as new subnet will now be 255.255.224. I remember what I said. Yeah, for you to get the incremental value, this 224 is the same thing as this is 11000000. Baby, this is
Yes.
the last high order bit, and this corresponds to what? This
60,
corresponds
32.
60, 32. Beautiful. 32. So that means the incremental value will be 32. So that means if we are stepping out this IP, we'll have 210. For this 100, yeah,
100, yes,
156.0.
100.56.0.
The next one will be 32, right? The next one will be
Yes,
64.
64.
64.
Okay. I think we
98,
can actually
96.
96. What again?
108.
108.
128, sorry.
28. What again?
Yes. 160.
160. If you added 32 to this, can we still go?
Yes. 190.
Oh, is it 32, 32, 64? Yeah. So, but we needed just
32.
yeah, we needed just 6. So this is 1, 2, 3, 4, 5, 6. So this is fine. Remember it was 8 because we used 3, 2 raised to power 3, 8. That means we'll have up to 8 networks.
Yes.
You get, so
Yes.
it's good. So that means we're just wasting 2, but that's the closest we could get to having 6 networks. It's better than wasting all the other ones. So 2 is fine. So that's what your network will be. So that's pretty straightforward. Let me take this out to another page so that we can then see what the ranges are.
Yeah, is it? Can we
Yeah.
round up so that
Yeah. We're rounding up.
2 minutes?
So, but you get how to get the hosts, right? The network 156 0, so 32. So that means this range will be 210 100. Sorry, 56.31, right? As the last network. Okay, so it's the same thing if you want to do for hosts. For hosts now, I'm just going to pick that same network. This same network, 210 100. This is the one we do for hosts. 210 100.56.0. The same network. .56.0. Now, if you want to like say, okay, you know what, subnet this network where I can have 30 usable hosts. So I say I want 30 usable hosts from this network. So what you do is the same thing, 2 raised to power n. What 2 raised to power n is closer to 30? That is 2 times 2 4 times 2 times 2 4 times 2 times 2 16 6. That is 2 raised to power 5.
Power 5.
Right? Yeah, which would be 32. Right?
Yes.
Which is fine because by the time we subtract 2, we are left with the 30 usable hosts. Now remember, for hosts, it is the zeros you are keeping. So that means I want to keep 5 zeros. So what that means is by the time I do my 111, 111, 111, you know how we do that, right? So when I get to the last octet now, so that means I'm going to reserve from the right hand side. So I'm going to reserve 1, 2, 3, 4, 5. Reserve 5 zeros, complete the remaining with ones to have my 8 bits, and then do my new subnet mask, which means that this will be 255, 255, 255.224. The same thing, you have your incremental value of 16. So you step it out. Incremental value of 16 already tells you that if you had one IP as .0, the next one will be .16.
16.
So that means you have 0 to 15, which means, oh, no. Are we doing 16? 2 to 4. It's incremental value of 32. This is 32 now. This is 1, 2, 8, 64, 32. Sorry. 32. 32 rather. Sorry. So this will be 31. So that means, yeah, so that means we have 30 usable IPs. So if you follow this, you begin to see a pattern. And by the time you see the pattern, my brothers, there will be no even need for you to subnet. You'll find out that, how do I make this so simple? You find out that 1, 1, 1, 1, 1, 1, 2, 3, 1, 2, 3, 6, 7, 8 is 252 and has an incremental value of 4. You'll find that 1, 1, 1, 1, 1, 0, 0, 0 is 248 and has an incremental value of 8.
8.
You begin to see patterns. 240 has an incremental value of 16.
16.
So if somebody tells me he wants an IP that can only house 2 hosts, it's as simple. I give him this subnet mask. It will always have an incremental value of 4, which means he can use his 2 usable IPs.
And the rest is the West.
So you don't even, so that's why you see, you get to a stage where subnetting is in your head. You are not, there's no time to go and start doing 2 raised to power, all that. You just tell me you want 16 hosts. I say, oh, you want 16. Oh yeah, take 240 as your subnet mask, because I know 240 will always have an incremental value of 16. It won't change, it's binary. So you get, so if just on your spare time, step it out till you have 1 0 0 0. So you can see all the combinations between this, and this, the incremental values, and then subnetting for host will be as simple as knowing what the incremental value is. So if I want to give you, if you say you want 30 hosts, I just give you a subnet that has an incremental value of 32, and that is 224. You get, so that's the beauty of that. So please do it on your spare time. I'm going to give you something. How do I give you guys this assignment now? Sure, I can paste it in the chat.
Can you, hello, can you just
Yeah,
document the assignment so that I'll just drop it on the Discord channel for everybody?
Okay. Let me discuss, because I have it in bits and pieces. Let me just show you an example. It's going to be interesting. So the way the assignment is going to be, I'll just share with you a network, switches, routers connecting. So you see marketing has 24 hosts, research has 60 hosts, management has 15 hosts. I'll give you a block of IP. I'll tell you to subnet it within those hosts, making the least minimum number of subnets or the minimum number of hosts without wasting IP addresses. So that is going to be something like that. So thank you guys. So once you do that, we meet on Saturday, we review it, and also give you some subnetting to further deepen your skills in subnetting. So thank you very much. I appreciate. So that I'll share it with you. Yeah, I'll share it with you tomorrow morning. Let me work on it and make it one document. Yeah.
All right. Okay. And thanks so much, Ese. Thank you so much. Thank you as well to everybody, without the sacrifices and all. Don't worry, we're almost there. We're almost there. But for now, we have to burn the night candles. So thank you, everybody. Thank you for joining in. And thank you so much, Ese. So Ese, I'll have to send you the Discord link so that I can also join our Discord channel. If anybody has any question, they can always reach out to you. Yes.
Okay.
Thank you so much, Ese. I'm so grateful. Thank you.
All right, bro.
All right, guys. I'll drop the recording on our Discord page so that you can always listen to it again. All right, guys. Thank you. Good night.
Good night.
Good night, guys.
Good night. Thank you.